Join me as we dive into blue carbon systems, the planet's built-in carbon sink. As natural carbon sequesters, blue carbon systems take atmospheric carbon and store it and keep it from re-entering the atmosphere. Blue carbon is a term that refers to marine and coastal ecosystems such as mangroves, tidal marshes, and seagrass meadows, as well as others like coral reefs, shellfish colonies, or kelp forests, all of which have this function of storing carbon due to the carbon cycle process. So let's get into it. So during the carbon cycle process, many reactions take place that involve the element carbon. Carbon is an element that's vital to all forms of life. It's inside of you and me. It's used in your bones and your skin. And it's even found in inorganic matter such as steel, diamonds, or even gases like methane. So the way in which carbon is carried into the atmosphere are through events like volcanic eruptions or wildfires sparking. In fact, wildfires and volcanic eruptions are two primary sources of natural carbon dioxide. And on the other hand, you have unnatural events such as the burning of fossil fuels, human-induced actions like in factories, which also contribute to carbon dioxide entering the atmosphere. So the way in which carbon comes back from the atmosphere is through assimilation, where life forms will go ahead and take inorganic forms of carbon, like carbon dioxide, and convert this into organic forms. For example, the trees or the grasses here, they'll go ahead and grab some carbon dioxide and convert this or use it to build up their branches or their leaves. And the cows here, like you and me, they'll go ahead and take this carbon and use it within their bones, their bodies. So essentially, carbon is just stored in the bodies or structures of organic beings. So here we have the carbon cycle pertaining to blue carbon systems. Specifically, we have some mangroves, tidal marshes, seagrass meadows, surprise, surprise. So what happened is these marine and coastal ecosystem plants will go ahead and take the carbon dioxide from the atmosphere. They'll go ahead and use it within their leaves, their branches, the stem, the roots, and then eventually they'll actually go ahead and sequester this carbon into the soil, which is actually a critical component to how these blue carbon systems work and function. So now I'm going to take you to a seagrass meadow. So seagrass meadows are usually found in shallow, brackish, or salty waters. Various species depend on seagrass meadows like seals or even smaller creatures like itty-bitty shrimp. And so seagrasses will essentially just store atmospheric carbon that gets pushed into the water inside their leaves, or eventually they'll go ahead and store it and compile it into the sediment that they create. So in Florida, we have what is regarded as the second largest seagrass meadow within the United States, and that is the Big Bend. So the Big Bend is over 984,000 acres long, with seagrasses spanning an area of 267,000 acres. And the Big Bend just demonstrates how vast these ecosystems are, as well as how they're living right in our backyards here in Florida. And it really just emphasizes the importance of us protecting and preserving these natural systems. So now we're at a shellfish colony. They're also a blue carbon system. So here you'll see a farmer tending to this mass cultivation of oysters during the low tide. So oysters have been around for millions of years. They date all the way back to the Triassic period. And as far as we know, the Greeks and Romans were some of the first to cultivate oysters for human consumption. So oysters have pretty decent history, and they've been around for a really long time, longer than us. So during their life cycle, oysters will go through various stages before they become what is arguably the most important stage in their life, which is a spat. So why is it the most important stage? I'll tell you. So an oyster, in order for them to become a spat, they must first attach themselves to a suitable substrate. So this could be a rock or maybe a boat dock or something. So if they don't attach to these substrates, they will die. So pretty important there. So they'll live for about 2 to 3 years, and farmers usually follow a harvesting schedule of 18 to 24 months. So here we have a slide that just shows the material that an oyster shell, I have one for you here, is made of. Pretty cool, right? So an oyster shell is made out of calcium carbonate right here. So if you see right here, this is a calcium carbonate molecule. So the calcium is this white atom right here, and it's attracted to this carbonate ion, which is made out of a carbon and these red oxygens here that are sharing electrons. So what'll happen is, just think of it like soda. You have carbon dioxide being pushed into the bottle. Same way the atmosphere goes ahead and pushes some carbon dioxide to the water. Reactions take place, and then eventually a carbonate, CO3 ion, is formed. And so what happens is oysters will go ahead and take this carbonate ion that's been formed in this water here, and this calcium that's drifting through the water as well. They'll go ahead and combine this and create their shells. So carbon essentially is 12% of an oyster shell's mass. So that's a pretty decent amount of carbon stored within these shells. So then here behind me, you'll see some limestone. If you're a Floridian, you should definitely know what this is, as it is kilometers deep down here. If you don't know what it is, are you really a Floridian? Anyway, so limestone just demonstrates this blue carbon process and takes it even a step further. It's essentially just shells or coral reefs that over time have become pushed together due to pressures and become the sedimentary rock. So essentially, carbon is stored here more permanently than any other type of system. So it's really important that we keep this in mind as a carbon storer. And it's also made out of calcium carbonate, if I did forget to mention that. And like limestone and oyster shells, reefs are also made out of calcium carbonate as well. So the reefs here in Florida, at the Great Barrier Reef, and in Belize. So essentially, what I'm trying to get you at is carbon is found everywhere on this planet. It's found inside of me, it's inside of you, it's in the cows, the trees, shells, fossils, your soda. It's found everywhere. And these blue carbon systems go ahead and take this carbon, especially carbon dioxide, and store it within their systems and keep it there for some time. So I want to go and continue exploring these blue carbon systems more personally, and I want you all to come with me. So let's all grab our life vests and get going.